lecture is designed to walk you through respiration and phonation coordination. So when we talk about respiration and phonation, we're talking about the breathing and how our breathing changes to modify and meet the needs of our voice. As far as the function of the body, respiration is ultimately the goal of the respiratory system and the phonatory system. So we want to have breathing, and we want to have safe breathing and a safe airway, which is ultimately that biological function of the larynx and the vocal folds, is to protect the airway. But because of humans and the modification over time in biology, we've equipped ourselves to be able to create voice. And so our respiratory cycles are modified with the signals from the medulla and the signals from into the cranial nerve through the vagus nerve to close the larynx and produce the voice. And so let's go through a less complicated way of talking about that, because in order to understand dysfunctional voice, we really have to understand how functional voice happens. So if you could hear the voice at the level of the vocal folds, and that's right here in the larynx, right about the level of the bump in your throat, then it'd just be a buzzing sound. If I say, ah, even now you're hearing sound that's been resonated through my throat and through my mouth and a little bit through my nose. And so that's not even the true vocal sound. That's been enriched and modified through resonation, which we'll talk about in the next lecture. But very simply, if we're talking about the function of the voice at the level of the vocal folds, then we're only talking about that cyclic motion. Just like if you strum a guitar, you're going to have that kind of sound coming from the vocal folds. And that happens as, if we imagine this being the vocal folds, and we'll have up here, this is the front of the vocal folds, this is the back of the vocal folds. They're going to come together and close, and the better the closure, the better the voice. So if I have a little bit of a gap in between my vocal folds, then I'm going to have more air coming through. If they're tightly sealed, then it's nice and closed, then I have a clear voice quality. So as the vocal folds are pulled closed through the intrinsic muscles, they're held closed, and air is forced through this closure. And because of what's called the Bernoulli effect, it's kind of like a vacuum, the vocal folds are kind of open and closed over and over again. And it's not a muscle motion, it's actually just the suction and the pressure change of the air. Okay, so the vibrations that occur as that air travels through is what actually gives us our voice. So in phonation, the muscles are pretty much passive. Once the vocal folds are closed, the muscles are just doing their job of holding that muscle closed as the air goes through. Okay? So let's talk about respiration. If we think of respiration on a very simple level, we can think of it as a balloon and a pressure system. So if we imagine that these are the lungs, these two black balloons, and this little balloon down here is the diaphragm. As we expand the diaphragm and that expansion in the thoracic cavity, then we're passively pulling the lungs open. So it's engagement of the diaphragm and some of the intercostal muscles that help expand the rib cage and inflate the lungs. So the lungs themselves are passive, but the muscles are active. We can imagine up here at the top in this blue is the larynx. And we don't have a good picture of it in this video, but just to give you an idea of what's happening at the level of the lungs, this is going to be during inhalation. So we're bringing air in, and it's just a pressure change. We're increasing that air as the diaphragm is pulled down, and it's expanding the lungs. And then we're going to have a different change of pressure. Now that we have positive pressure or too much pressure within the thoracic cavity, we're going to decrease that pressure by relaxing the diaphragm and collapsing the lungs, and that helps that air flow out during expiration. So I have a little diagram for you. So we have the external intercostals that are going to move the ribs outwards, and these are active muscles during inhalation. Okay, so active during inhalation. And that creates negative pressure. And I always think of during inhalation negative pressure, if we just nick this little I over, it gives us a negative sign so we can remember that there's negative pressure. And that means that if we're looking at the molecules in the lungs, we have lots and lots of space in between each molecule. Okay, so that's where our negative pressure comes in. And that causes us, because we want to have equal pressure to the environment, it causes us to pull the air in through the nose or through the mouth into the lungs. As we fill the lungs, we get positive pressure because we're adding more and more air molecules, okay? And so this gives us where we need to switch into the exhalation or expiratory cycle. So this is where our internal intercostals are going to compress the rib cage. And this is essentially everything's been pulled open during active inspiration. It's just going to relax back down during passive expiration. Okay, so we have that positive pressure pushing the air out of the lungs are relaxing, the muscles are relaxing, it's just flowing out of the mouth, and it's emptying the airs. Once we have that as empty as we can go volume of air in the lungs, we have our expiratory volume. We never have an expiratory volume of 0 because that essentially means that our lungs are deflated. So there is at least some pressure within the lungs at all times. Okay, so how does phonation fit into this cycle? If you try and talk on inhalation, I want you to try that now. What does it sound like? 1, 2, 3, 4, 5. And it's us working against our system. So we're designed to talk on exhalation. So before we start a phrase, we're going to bring in what we think is enough air to get us through the phrase, and then we'll pause appropriately while we're talking and going through those sentences. And our body tells us we need to stop a sentence just in time to take another breath during inspiration. So if we're thinking of phonation, again, it's just filtering puffs of air through the vocal folds. And the change in the puffs of air occurs, there we go, as the vocal folds close and vibrate. And we can change the way that that sound is interpreted, or as the sound is changed, by changing the shape of the vocal folds. So our myoelastic aerodynamics theory tells us that we have the vocal folds actively controlling the tension as the air flows through them. So when we talk about the negative and positive pressure of the Bernoulli effect, we're talking about the positive pressure that's here right underneath the vocal folds that's coming from the lungs. We have the negative pressure between the vocal folds, and as that air flows through the vocal folds, then we have that cyclic motion of the vocal folds opening and closing over and over again. Okay, and so that closure is, again, it's an active closure of the muscles, but it's passive cyclic motions. Okay, and to orient you, this is the side of the vocal fold. So if we were to cut ourselves in half this way and just look at the vocal folds instead of from above, this is what it's going to look like. So the vocal folds are actually very thick, and that's going to come into the next section of this lecture. If we're looking at this picture over here, this is a picture if we go through the nose, down the throat, and look at it from above, we can see this image. And we have the vocal folds here. You should be familiar to this one. And so here we have the back of the vocal folds, because these are the arytenoids here. And our vocal folds always come to a V, and the point of the V is at the front of the throat right here. Okay? So if we press play, that's the same effect as what we get in this image, but we only see thin bands of tissue from the top. But keep in mind that they look like thin bands of tissue, but it's really a whole mass of tissue that exists below this image here.